Hi friends, in this video we would like to discuss about circuits laws. There are two laws we have. The first one is Kirchhoff's current law, and I can write it as KCL, Kirchhoff's current law. So as per the definition of this KCL, I can write it works on the principle of law of conservation of charge. Law of conservation of charge. Okay, so KCL states that algebraic sum of the currents at any point or meeting point is equals to 0. The statement I will give you. What is the statement? The sum of, or else you can write the algebraic sum of the currents at a meeting point, or no, we can call is equal to 0. So I can give you, suppose there are different currents are coming or moving at this node. Okay, you can take this point A, and the current flowing, that you can take I1, you can take I2, this current is I3, this current I4, you can take this current I5, you can take this current I6. As for the statement of KCL, I can write at this point, a particular point, at this point, sum of all the currents moving or meeting at this point is equals to the 0. Based on the direction I can write, if the current is coming towards, if I can take it as a plus, and if the current direction or current is moving away from the point, I can take it as a negative. Or else you can define the KCL also. All the incoming currents is equals to outgoing currents at a node or point, This also can write, okay, all the incoming currents is equals to outgoing currents at a node or point. That is also you can write the statement for KCL. So from the above diagram, I can write what are the incoming currents I1, I3, I5 and I6. So you can write I1 plus I3 plus I5 plus I6 is equals to outgoing currents. What are the outgoing currents from this node? You can take, that is I2 plus I4, that is also outgoing. And is there anything? No. So I2 and I4 are outgoing currents and remaining currents are incoming towards the node. So as per the statement, algebraic sum of all the currents is equals to 0 at the meeting point. So I can write the same, that also I1 plus I3 plus I5 plus I6. If you bring this I2 this side, you will get minus, and you can write I4 minus, which is equals to 0. Both are same, don't confuse. Okay, right? So this is about the KCL. So related to the KCL, I can define what is the current division rule. Okay, current division rule. So if the two resistors are connected in parallel with a current source, the two resistors are connected in parallel with a current source I. Okay, then you can take this is the current I. Okay, and the current which is flowing in this you can take that is I1. In this you can take that is I2, and the total current is I here. Okay, then I can write I1. This resistor is R1. You can take this resistor is R2. So I1 I can write it as I1, which is the current flowing through the R1 resistor. Total current, if you write, into which branch you are finding the current, opposite resistance, you can take that is R2 by total resistance R1 plus R2. Similarly, you can find I2, which is equals to total current I into opposite resistance R1 by sum of the resistance R1 plus R2. Yes, so this is applicable for all the passive elements, not only resistor. You can write for inductor as well as the capacitor. So you can write that it is applicable to parallel connected elements. Parallel connected elements. Suppose in case of AC, if the inductors are connected like this, okay, two inductors are connected parallel. Okay, let's you can take this is L1, L2. Okay, and there is a voltage source is connected here, and the current flowing through that also you can write, and directly writing current source for easy understanding purpose I, and the current flowing in this you can take I1, and in this you can take I2. So I1 I can write the total current into opposite resistance inductance, that is L2 by L1 plus L2 I can write. Similar fashion I can write I2 equals to I into L1 by sum of the inductance L1 plus L2. The same manner, if in place of inductor I am connecting a capacitor. Okay, these two capacitors are connected in parallel and excited by a current source which having the current value magnitude I, and this you can take C1 and you can take this is C2. The current flowing that you can take I1, this current you can take I2. So I1 I can write the total current into opposite capacitance, that is C2 by C1. Yeah, so here you can write the same capacitor. Okay, keep in mind, you can write in case of capacitance, you can write the current which branch you are going to find in. The same capacitance value you can take, that is I into C1 by C1 plus C2. Whereas I2 current, if you want to find in the capacitance C2, the total current into C2 by C1 plus C2. The same capacitance you have to consider. Okay, so I will stop here. In next class or next video, we would like to discuss about KVL and voltage division rule. Thank you.